Demonstration of high-precision cutting of tube-type supports using Hans laser femtosecond laser. Precision machining of medical stents has almost stringent requirements for cutting accuracy, material integrity, and biocompatibility. The infrared femtosecond laser, independently developed by Hans Laser, with its cold processing characteristics, can avoid material thermal deformation or tissue carbonization and maintain metal biocompatibility. At the same time, the femtosecond laser focuses on a very small spot to achieve micrometer level cutting, ensuring consistent support rib width and meeting the processing requirements of complex mesh structures. In addition, this femtosecond laser is widely applicable in materials and can achieve diversified processing of metal scaffolds, such as cobalt chromium alloy and nickel titanium shaped memory alloy, as well as bioabsorbable non-metallic scaffolds such as PLA and PLLA. The equipment can be equipped with automatic loading and unloading, visual monitoring, rotating work table, etc., to achieve automated large-scale precision production.